Okay, hello and welcome. Talk I'm giving today, the other Apache technologies your big data solution needs. So I work for a company called Quanticate, and we're just starting to do things with big data. And as part of that, I've been doing some investigations into various Apache technologies out there that we should be using. And in general, I do help out with the Apache Software Foundation, and I've been trying to learn quite a bit about the different projects that are at Apache. I'm going to try and give you a whistle-stop tour through some of the projects that you should know about. So when you're building your solution, you can avoid reinventing the wheel, or at the very least, avoid giving it only with 3 sides. So, the ASF, Apache Software Foundation. There are currently 117 top-level projects, 37 incubating projects, so that's a lot of different projects out there. If you were thinking of bringing one to the foundation, Y is the letter to go for. It's the only one in the alphabet that we don't have a project starting with. And we try and do meritocratic, community-driven open source. So the foundation has been growing, which means every time I give this talk, it gets harder, because there's even more projects involved. But we're now up to about 150 different projects out there. Not all of them relate to big data, but a surprising number of them do. So what am I not covering in order to fit this into 40 minutes? There are a few projects that are already being covered here at Berlin Buzzwords that have got their own sessions, so I'm skipping those. So they're mostly the big name ones. So not covering any of those or any of those. If you want to know about those projects, you need to just look through your schedule and find the sessions on them. So, having excluded the very biggest projects, that does still leave quite a lot to be done. So I've tried to break the list of projects up to give a bit of structure. So firstly, I'll be looking at some of the projects that make it possible to load data in and query it. I'm going to look at some of the projects that make it easier to build Mapreduce jobs. I'm going to have a look at how to deploy and build for the cloud for big data solutions, looking a bit at some of the server technology related stuff. And then finally, a number of the other projects that help when you're building the complete solution. Now, I've not got that much time. There's a lot of projects, so I'm only going to give you a bit of an overview. It's not a complete introduction, but it can hopefully whet your appetite and let you know which sort of things to be looking at. So, I need a bit of a show of hands to work out which projects to focus on and which ones gloss over. So if you consider yourself a developer, can I see hands up? Okay. If you consider yourself to be a sysadmin, a few of you, okay. And if you consider yourself to be kind of in management, project management, anything like that, a few of you. Okay, so I will try and mention almost all of the projects I've got slides for, but I'll dwell more on the developer-related ones. For the others that tend to be more sysadmin-y or that sort of thing, you will be able to download the slides later and have a look through, and then come and find me at 6 o'clock with a beer, and I will happily talk to you a bit more about those projects where I know about them. So, slides will be available. I'm going to cover an awful lot. I would advise not trying to take notes. I did once see someone try, and it wasn't pretty. Just try and remember the projects that seem interesting. At the top of all the slides, I'll try and give the project URLs. Go away later, have a look, see if they're still relevant to you, learn some more from that. So, first up, loading and querying. Pig, originally from Yahoo, went through the incubator, now quite widely used. And it's an easy way to query your data in Hadoop Mapreduce jobs. Typically, I'm told, it's about a 20th of the line of code that you would involve if you were to be writing in Java, and it takes about a 15th of the time, which is good. But it's not SQL-like, which can be an issue if you're trying to give it to BI people, data scientist people who are only used to SQL-like ways. It's usually nearly as fast as writing the Java yourself, but just a lot quicker for you to write. So there's a scripting way through the shell or embeddable Java, and it has a local mode for development, which is important so that you can test what's actually going to happen before you let it loose on your cluster and have it run for a week. It's got built-ins for a lot of the common stuff you're going to do when you need to load in data or save it out and filter it. And then it's got hook points so you can write your own custom UDFs and inject them and do your logic that way. Similar range of functions to SQL, but it doesn't look like SQL. So it is possible for BI people to use it, but they need a little bit of training, a little bit of hand-holding, convince them that it is worth persevering with. Gora is an ORM framework for NoSQL, which maybe seems a bit odd, but since you think, well, it's not SQL, why would you try and map it like that? But it does seem to be useful for people who want to deploy to multiple different systems or want to have a layer of abstraction. Originally, it came from Apache Nutch, who found themselves wanting to separate that out. It currently supports HBase, Cassandra, and Hypertable on the column store front. It also has some support for key value stores and flat files. The way it works is by encoding it into the data into Avro, and then it gives you ways to query it through Java. There's a Java API, but you can also query it with Pig, Lucene, Hive, and a few other things. So this is just a little example. If you wanted to get started, you just define some fields, Avro bean, and then just nice, simple Java API, and away you go. So if you are not sure about which column store family you're going to be targeting or anything like that, and you want to get up and running, you can maybe use something like Gora to abstract that away, and then you can change the back end while you firm up your plans. Maybe later on you'd want to move to a native API, but in the early days that could be helpful. Accumulo is distributed key value store built on top of Hadoop, Zookeeper, and Thrift. You'll hear a lot of the projects I mentioned will be built on technologies like that. It's inspired by Bigtable, but they've tried to fix some of the design issues with it, and the important one that they've tried to introduce is permissioning. The original work came from the NSA, so you can see why they might be interested in doing some permissioning on top of these kind of things. So you can have cell-level permissioning to control what data someone can read, and then you can also have write constraints, so you can say a particular user can read but not write. And then it's got some nice little server-side hooks that mean that you can manipulate the data as it's going in or coming out. And it supports very, very large rows, so it can work with data that's too big to fit into memory all in one go. Has high availability using Zookeeper, and it's got some nifty stuff with distributed write-ahead logs that allows it to be high availability and only write to HDFS later. It supports logical time, which is good, so that if different machines have different ideas about what now is, you can still get some sense out of it. It's a lot cheaper than what Google have done, which is to just go and buy a few atomic clocks for every data center. That does work, but your budget is kind of a bit different. Very testing friendly. They've got lots of mock objects you can use, functional tests, scaling tests, random walks. And if you were in here earlier hearing you talk about some of the work that Lucene have done with random testing, you see that that's worth. Scoop, it doesn't have a U. You will get confused and not find the website if you try typing a U as I did. It's a bulk data transfer tool for getting data in and out of big data systems. So for example, if you've got a giant relational data warehouse and then you've got your shiny new Hadoop cluster and you want to make the two talk to each other, you can make use of Scoop and define very quickly a way to pull the data across. And then when you're done doing all your comparisons and calculations on Hadoop, you can then push it back in so that your BIs can make use of it and work with it in the tools that they're used to. Chukwa. It's been in the incubator a while, so it does seem to be having some issues with getting enough traction. But it's a log collection analysis framework for Hadoop, for pulling in all sorts of logs from many different systems that you might have out there, getting them into Hadoop so you can analyze them. So it's all very well having 1,000 web front-end nodes that are all logging away, but if your only mechanism is SSHing into every machine and running a grep to find out what's going on, you're not going to get a lot of value out of those. So using one of these log collection frameworks, you can suck it all into somewhere and do the analysis and get useful stuff out of it. So it lets you collect and aggregate logs from many machines and then put them up into chunks in HDFS so that you can query and analyze them later. You need to have a little agent running on every single node that can collect from all the standard kind of sysadmin-friendly logging sources, and then it sends it to a special collector running on the Hadoop node, and that can do transformations. And you'll often want to also write it out into HBase so that you can do pretty visualization, and then after that you can do your Mapreduce jobs and Pig and so on. Netflix are one of the big users of it, and they do some nifty stuff where they have all of their web front ends logging. That goes through Chukwa. Chukwa does some transformations into thrift packets, stores them in HDFS, and also stores them in Hive, and then people can go and run nice queries against Hive and see what's popular at that moment in time on their front ends. An alternative, trying to solve the same problem but taking a different approach, is Floom. Floom concentrates on getting the data off of the remote servers that are generating the log data and into Hadoop as quickly as possible. So it's all about the quick throughput and getting it ready to be analyzed. Typically, you would actually have it going into several different stores, HDFS, so that it's there for bulk, Mapreduce, put it in Hive so you can do nice visualizations, and full text search so you can query it and find out what's been going on. It's got slightly different terminology, but you have sources which suck in the original events, and then channels, which is where it puts it pending delivery, and then sinks, which are the things that actually write it out into Hadoop or whatever. It can do one-to-many, many-to-one, all that kind of thing. It's very easy if you want to add in new sources. So if you've got your own custom logging source, that's easy to put in. But if you want to do really, really custom things, you might be better off with Chukwa. Floom is much better for just, how do I deploy this, get it out of the box and working. Apache Blur incubating project is trying to make it easy to search structured data. A few of the Lucene people I've mentioned it to have raised eyebrows, but people do seem to be interested in it. And it's a way of being able to do indexing and searching across large volumes of data that you've already got stored in your Hadoop cluster. So it runs Mapreduce jobs to suck in the data off of HDFS and put it into Thrift, and then index that, and then distribute the shards across a cluster so it's all nice and fault tolerant and shard failover and so on, and then finally gives you a web-based query interface where you can send in queries that will get distributed out to the different shards, run against the shards and get your answers back. So if you've got lots of data and you want a relatively easy way to be able to search through that, it could be worth a look. Falcon is trying to give a complete data lifecycle management for the data in Hadoop. Rather than you just saying, well, I'm going to have these jobs, they're going to write into Hadoop. Sometime later, we might think about what to do with them, or maybe we'll just buy an extra cluster because it's cheaper to buy another rack of machines with new hard disks in than work out what the hell to do with the data we've already got. If you use Falcon, you can try and bring some order to all of that. Rather than you trying to implement a life cycle and retention policies and so on in your code, you can use Falcon, which has got its own set of unit tests, shows that it largely works, and then just hook into the components and that. So you say, well, data coming in initially needs to be replicated, then don't bother replicating it until we finish processing it. But once the process is finished, I also need a copy of that. And I need to keep at least one copy around for a year for regulatory purposes. So if you've got those kind of data flow, data lifecycle things, don't roll your own badly. Use something like that. Hammer is an alternative to something like Mapreduce on Hadoop. Rather than implementing Mapreduce, it does bulk synchronous parallel processing. There's some good papers on that if you're interested. If you go and learn a bit more about it. But it works well for matrix operations, graph algorithms, and network algorithms. And it also generally works a lot better than trying to do the message passing stuff yourself. So if you've got the kind of problem that's not mapping well onto Mapreduce, but is a bulk thing, and you've got those kind of algorithms, have a look at maybe doing it with Hammer and BSP rather than doing it with Mapreduce. Miracle, MRQL, but it's kind of a nice name. It's a large-scale data analytics engine that can run on top of Hadoop with Mapreduce jobs or on top of Hammer with the BSP jobs. It has a SQL-like query language, which I gather is important for the BI people who get scared when it's something that's not SQL. And it has a lot of complex types and constructs that are there already. So whereas with Pig, you might end up having to write a little bit of Mapreduce stuff yourself when the standard query won't do it. In theory, Miracle should have all that there. And it can do the page rank and k-mean and all those kind of things quite nicely, very small sets of code. I think this is pronounced Tahoe, or maybe Tayo, not sure. It would be great if more projects had a little pronunciation guide on their site. It would also avoid all those issues about is it GIF or GIF or whatever, if they announce it up front. So, data warehouse system for Hadoop, which is trying to do low latency queries. Some of the other things are designed more for very bulk parallel operations. This one's much more about how do I get a quick turnaround for my queries. So it uses HDFS for storage. Almost all of these systems use HDFS, the Hadoop file system, to store their data. Some of the interesting things come about when they come to query it or analyze it. So with Tayo, they've got their own query engine that does the executions and optimizations. And it will run apparently native SQL queries. It will do filtering, grouping, sorting, joining, and so on. So most SQL queries will run against it, and then it will query against your big data stored in HDFS. So now on to building Mapreduce jobs. If you've decided Mapreduce job is the way forward, let's have a look at some of the things that you can make use of. Avro is one of the two language-neutral data serialization projects at Apache, Thrift being the other one. The idea with these is when you're storing the data into something like HDFS, you want to be able to query it and get the data back out from lots of different languages. If you only have one language that can read and write it, you restrict what other teams can do with it, you restrict what interesting uses you might be able to come up with for it later. So Avro uses a JSON-based format to do the storage, and then it has a binary data representation from that. So you define it in JSON, and it gets stored in a binary structure. If you're using dynamic languages, you can skip the code generation step if you want. Obviously, if you're using statically typed languages, you're going to have code generation for all the standard getters and setters and so on. It does support RPC, and the data format always includes the schema. So if over time your data structures change and you add new fields and so on, you can always figure out what the structure was at the time the file was written, which is often handy if at the start you're not sure what it is exactly you're going to be storing going forward. So the schema is always present, which means you can do dynamic typing in dynamic languages. Supports a fair range of languages, and the different languages can talk to each other and make RPC calls by passing the data structures around. And I'm told that it's often faster than Thrift and Protobuf. But the downside is that everything has to be loadable into memory. There's no streaming support. So if you've got a small amount of metadata and then multi-gigabyte video files, it's not necessarily going to be the best fit for you because you've got to be able to buffer it all up into RAM before you can do anything with it. Thrift takes a slightly different approach. Thrift originally came from Facebook, but is now very widely used. It does have RPC support, and it has streaming support. So if you need to be able to work with only part of it and direct the data off, it might be a better fit. But it compiles down into code, so there's less metadata available with the data at the time of use. And if you're interested in any of this stuff, their white paper is really accessible and really interesting if you want to understand more about the data structures and the way of making it all work. hcatalog is trying to give you a table structure on top of raw HDFS files. So rather than just having HDFS files that contain random binary blobs that you can't make sense of, you can just put a bit of metadata on the front. It actually uses Hive's metadata format. Pop that on the front of the file, and then you can more easily query it. So from your Pig jobs or your Mapreduce jobs, you can then load in these blobs, make sense of them, process them that way. And it doesn't require additional data stores, so it can still work on top of straight HDFS. But what you do is by putting this metadata on the front, it's then easier to work with. MR unit is unit testing, which is important. There will be a few people around who maybe over a beer can tell you some horror stories of what happens if you don't properly unit test your Mapreduce jobs, and then you discover that this job's been churning away at the entire cluster for 2 weeks and no one else has been able to get anything in. And at the end of it, you get duff data out because no one tested it. That's bad. So it is important to do some unit testing. There was a talk this morning on some really advanced unit testing that you can do. You can use MRUnit for some more basic stuff. It gives you all of the objects you need to test all of the different components individually without having to spin up a huge Hadoop cluster just to work out that you've got one of the inputs wrong. And you can, because you've got real kind of fake Hadoop bits, rather than having a load of brittle mock objects, you can actually play with all the different bits individually and check that they glue together. This is an example to show how easy it is to get a simple unit test up. We've got about 15 lines there. That's a Hadoop unit test. Hadoop development tools it's a very new project, only just come into the incubator. The idea is to provide a load of Eclipse plugins to make it easy to do Mapreduce development and Hadoop development in Eclipse. One part of that is being able to work with multiple copies of Hadoop in a given Eclipse instance. The other one is to do Eclipse integration for a lot of the common tasks that you need to do as a developer. How do I query the cluster, find out what it's doing? How do I submit my job once I've got it compiled and building in Eclipse? If I want to submit that to the cluster, how do I do that? And importantly, when my job's going a bit wrong, how do I attach the Eclipse debugger on my current machine to that Hadoop cluster over there where my code's breaking to work out what's going on? Not all of that is there yet, but it's something to keep an eye on, and hopefully in 3-4 months' time, a lot of that will be in place and you'll be able to work within Eclipse if that's your preference, but then work against Hadoop. Oozie is workflow and data workflow scheduler and dependency manager for Hadoop jobs. So let's say you've got some raw log files that you're going to need to do some initial analysis on, and then you're going to split that out into a keyword analysis and a user agent analysis, and then you're going to do a count job and slice it up by time. Some of those have common parents, and you don't want to have to rerun the whole process when you come to do the second bit of analysis. So if you can define a workflow and a data flow, then you can use Oozie to spot when part of it's already been done and reuse those intermediate steps, recalculate the whole thing if it's changed. So it lets you define these data pipes and then say, dear Hadoop cluster, please make that happen and give me some nice results out at the end of it. Big Top is one possibly a bit more for the sysadmins out there. It's a way of letting you build and package Hadoop-based systems. For example, you would want HDFS and Hadoop Core and Zookeeper for your given setup, and then you need to deploy that out to a cluster. If you use Big Top, you can then generate all the packages for that. You give to your sysadmins that they can push out with something like Puppet. But then equally, you can say, well, what happens if we upgrade to a newer version of Zookeeper? Will that break our setup? Is that still compatible with the old version of HDFS that we're using? And it will let you do integration testing across the whole stack to work out whether or not an upgrade is going to be a trivial thing or it's going to be a massive amount of work. Ambari is monitoring and lifecycle for a whole Hadoop cluster. So if you want, you can use something like Big Top, build up the packages, and then deploy them using Puppet, and your sysadmins can have full control over it. And Ambari is trying to take it up a bit of a step and then have a REST API where you can say, Ambari, I need a cluster with Zookeeper and Pig and HDFS core. Please go and make it happen. So it's bringing it up the stack to make life easier. You get less control over it, but then if you've got developers who need to deploy code, who don't want to be messing around with Puppet and building packages and things, then Ambari might be better. It just depends on the kind of sysadmin skills you've got in-house, the kind of op dev skills you've got in-house, the speed of changes that are being made. But this potentially can let you spin up a particular set of machines a bit more quickly. So moving on, so looking at some things for sort of cloud scale deployment and very large big data deployment. Provider-independent cloud APIs. Sounds a bit of a mouthful, but you probably want one of these if you're going to be deploying to public clouds. So it lets you provision and manage and query without using an API native to that provider. So when that provider does something silly or changes their pricing or someone new comes onto the scene, you can then just change a configuration file and say, today we're going to be talking to Rackspace because they've given us a good deal, rather than saying, okay, to change from EC2 to Rackspace, we've got to rewrite everything. So typically they do all the basic stuff: create, start, stop, reboot, destroy, tell me what's running. libcloud is aimed at scripting. It's mostly in Python, and you just write a 10-line Python script, and up comes Cloud Instance running on EC2 or Rackspace or whatever. So that's one option if you like writing scripts to do it. The other option is Delta Cloud, which has an XML REST API. And with that, you can just post a snippet of XML to it, and it will spin up a machine, and then you do a query, and you get back some XML telling you what's currently running. When you start playing with these things, it's very easy to accidentally run up a huge credit card bill. The querying is important. And having a cron job that periodically emails everyone and says, do you know that we've currently got 75 large instances running on EC2 and have had for 4 hours? Is that deliberate? Rather than the credit card provider ringing you up and going, I'm sorry, but you've reached your limits because someone called Amazon Services EU has just charged $6,000 to you. That one's a bit more of a problem. So even if you're not going to use anything else from it, maybe have one of these running in the background warning you that you've spun up a load of EC2 instances and then gone off on holiday and forgot about them. Provisioner tries to be at a higher level than all that. Those two tend to be more aimed at people thinking about individual machines, provisioning them, bringing them up, stopping them. Provisioner tries to come higher level, and you go to Provisioner and say, I need a cluster with 10 machines in that's going to have this kind of structure. And then it builds on top of Puppet and creates the machines and then uses Puppet to deploy all the code to them. And it handles all the retries and the throttling and everything like that to make your cloud just come up. And uses provider-independent cloud APIs, so you can say, please bring up a cluster split into 2 parts, 1 part on Amazon in Europe, 1 part in Rackspace in Texas, and bring the whole lot up. Or you can go further down and use something like CloudStack to run your own private cloud. It's got all the software you need to do your own IaaS cloud compute platform, much the same as your own little mini Amazon. It works with all the standard hypervisors. It's got nice RESTful interfaces, web interfaces, CLI tools, and it can pretend to be EC2. If you've got some code that's already written to talk to EC2, you can just change the IP address that it's going to talk to, and it can talk to CloudStack. So there's a lot of tools out there that will let you pick the point in the stack that's going to be right for you to target. If you've got lots of sysadmins, lots of DevOps people, maybe you can go quite down low. If you've mostly got lots of developers and some VC money, but no sysadmins, and you just want to throw a credit card at the problem, you can look at some of the technologies that bring it higher up the stack, and you can say, look, here's a credit card, and I need a 10-node Hadoop cluster, and I needed it 10 minutes ago. Just go make the problem disappear for me. So, some service-related stuff. Zookeeper is a whole load of low-level services and building blocks that let you do configuration and naming and synchronization. So when you start trying to bring up a whole load of different machines, it's not very good to have the sysadmin go around and log into a machine and say, right, I need to start this service on here and this service on here, and it's just broken, so let me log into it over here, make some changes. So you use Zookeeper, you can define up front what should be going on, and then your systems can automatically come up. So when we were looking at the start at some of the solutions, a lot of those use Zookeeper so that they can do the high availability and the automatic naming and numbering and all that sort of stuff so that a system can just come up. But if you're not going to use one of the standard tools, but you are going to bring together lots of different components into a big cloud system, you should be using something like Zookeeper. Don't try and write your own distributed system for working out which one's going to be the leader. You're almost certainly going to get it wrong and have bugs. Get one that someone else has already bug fixed. So Zookeeper It's distributed, highly reliable. It's not a single point of failure. And it has all the primitives you need to do consensus tracking and groups and subscribe and that sort of thing. It's often described as a central nervous system for distributed apps and servers. And it's got bindings for all the languages you want to use. Alternately, go a little bit higher up and use Curator, which is a keeper for Zookeeper. So it provides out-of-the-box implementations for a lot of the stuff you'd end up writing on top of Zookeeper. And it deals with retries and error cases and that sort of thing. And it's got some very nice test support that allow you to bring up a little unit testable in-memory Zookeeper cluster and work with that. So if you want to be doing a lot of the standard stuff, potentially use Zookeeper, or possibly now that Curator's out there, what you should be doing is going to Curator and using one of the standard operations built into Curator and have it deal with Zookeeper for you and just say, I need the machine to come up and connect to the cluster and work out what its number should be. And just write 2 lines of Curator code, and underneath there'll be a couple hundred lines of Zookeeper code, and underneath that it all works. Don't try and write your own distributed stuff for this. It's really, really hard. If you are smart enough to do it, go and join one of the existing projects. Erivata is a toolkit that lets you build, manage, and monitor very large-scale applications, but it's workflow-driven. So you can define a workflow. It actually uses the activity workflow engine to do a lot of it. And it was originally there for scientific processing, and it's expanding out. And end users can define the workflows and then launch and have the data processing happen. Were grew from Hadoop, and you've got some high-level services that you define and say, look, just go off and make this stuff work for me. For more the Java developers out there, I've been mentioning some of the tools that you can use for deploying whole Hadoop clusters. But if you need to deploy some quite complex Java stacks, and especially if you're using OSGI, then you can use ACE to deploy out. It's OSGI itself, but it can work for most things. And think of it as a Puppet at the OSGI level. So it does all the kind of stuff that Puppet would do, let you track and configure and roll forward and back and all that sort of thing. But it's there at a high level if you're using OSGI for your large-scale Java stuff. Apache River is a toolkit for building distributed systems. It's a little bit like Zookeeper. It's been around for longer. It uses JINI for a lot of things. So if you're in an organization that's already doing a lot of Java stuff, a lot of Java naming stuff, and the way that Zookeeper names and addresses things is looking a bit alien to you, you should have a look at maybe using River. If you're coming to it fresh, you may be better off sticking with something like Zookeeper or Curator, which are newer and seem to have a bit more momentum behind them. Helix is a cluster framework, cluster management framework, which is based on a state machine. So you say, you define states and transitions and define how it should handle if things start to go wrong, when new things come up. And then you can define jobs that should happen at certain points in time. You should say every 6 hours, this job needs to be run once on the cluster or once in each region or zone. So you can define how to bring up an entire Hadoop cluster, have it run, what to do if machines start falling over, and then also make sure that the backup happens once, not 0 or 2 times, or your maintenance. So you literally have a sort of globalized brain for the whole system. Knox is, think Fort Knox security and so on. So if you're spinning up random Hadoop clusters on public cloud systems, there's a bit of a security issue there, which is if you've got your Hadoop publicly available to everyone, then anyone can come along and log into the admin system and it's still got the default password and all that, that's bad. So the idea with Knox is that you have your Hadoop cluster come up all on private addresses, and then Knox acts as the interface between the outside world and your cluster. So your user will connect to Knox, authenticate to Knox, and then they'll submit their job through and fetch the data back. So it's a sort of choke point Hadoop level application firewall. Mesos is trying to do virtualization on top of your cluster. So you've got your cluster there and running, And you've got the engineering group who want to be able to run the latest version of Hadoop to test out the code. And you've got the BI guys who want to have a nice stable Hadoop cluster running one from 6 months ago. And then someone else wants to try out an MPI job. You can use Mesos to deploy in the different versions on top of the same machines, and then have different clusters running on top of the physical machines and people doing different things. So if you've got sort of 2 racks of your own servers and lots of people calling to do different things on it, one option is to virtualize the whole thing and then spin up new virtual servers on top of it and let people deploy their own things. Or alternatively, you can use something like Mesos and virtualize the applications on top of the machine. You can slice it different ways depending on what seems to work best for you. And then finally, we've only got about 5 minutes, I'm going to run through some other projects that might help you round out your solution. So if you're dealing with binary documents that are coming in from different places, Tika lets you get out the text and metadata from them. It's often used if you're building search-based systems because the internet and file stores are full of random PDFs and Word docs and images, and you want to get the metadata and text out. And Tika can give you a consistent interface to all those documents. UEMA lets you get useful information out of unstructured blobs of text. You can do that with C++ or Java. It's the main technology that was at the heart of the IBM Jeopardy win. So they just had dumps of Wikipedia, dictionaries, and all that sort of thing. And UEMA let them pull out the text, and then they had all sorts of interesting code on top that weighted it all and made it work. But if you've got lots of text that you need to try and get information from, UEMA could be worth a look. Or alternately, OpenNLP, which does natural language processing. If you need to be tweaking and you've got academics who want to play with different models, OpenNLP might be better. If you just want something that's more turnkey, UEMA is probably the one for you. If you've got clinical data, which is something close to my heart with my current company, CTEX sits on top of both UEMA and OpenNLP and tries to pull out useful clinical data from the unstructured notes from clinicians and try and map it into different bits. There probably are other projects out there that do the same kind of thing for other knowledge areas. So if you have got lots of unstructured text, start looking at extensions onto UEMA and OpenNLP that can turn that 1 megabyte block of unstructured text into something that you can work with and then analyze and then throw at your Hadoop cluster. Mina is a framework that lets you do highly scalable network apps. So if you've got a really, really big Hadoop cluster that's doing lots of stuff and you need to talk to external systems, you don't want to have a single-threaded network server somewhere in the middle because that's all just going to melt when the whole Hadoop cluster tries to talk to it. So if you do find yourself writing network services for a big scale, Mina could be worth looking at for a lot of the basic building blocks to use. Or alternatively, Etch is a slightly higher level thing trying to solve the same problem. With Etch, you write a formal description of the messaging framework and then it compiles it down into the high-performance network code for you. You're probably going to need queues at some point. One option is you can use some of the primitives in something like Zookeeper, or alternatively, pick one of ActiveMQ, Cupid, or Snaps based on the languages and the way it slices down. If you think you need a queue, go and read their websites and pick the one that looks right for you. They're solving the same problem, but it's the way they attack it may be a good fit or a bad fit for you. And putting 3 message brokers on the same slide is definitely buzzword compliant. Kafka is doing push-pull, again, trying to pass the messages around and queuing. Takes a very different approach, but could be worth looking at. How are we doing? Almost out of time. S4 is trying to let you work on continuous streams of data, do processing on the stream rather than buffering it all into memory, working your way through it and spitting it out, trying to do real-time work on the stream. Apache Commons has huge numbers of libraries that let you do a lot of the stuff that you're going to need to do. The ones that might be relevant to the big data one will be CLI for doing the argument passing when you bring it up, Codec for working with the different encodings and compress, and then if you want to do your own processes that are going to start and stop and Windows on Linux and everything, then Daemon could be worth a look. JMeter lets you do load testing, so if you've got external servers that you're going to be talking to, JMeter will let you work out whether or not that'll cope before you have 7 racks of machines all trying to talk to the same thing that's melted and sysadmins are shouting. if you've got repositories, document repositories, document management systems, Apache Chemistry gives you a rich view of the data in them, a whole load of different languages that you can talk to, but it'll let you connect to your document management system, navigate around, check the permissions, check the metadata. Or alternatively, Manifold CF, it's a just sort of hoover for a lot of these document management systems that's just aimed at ingesting all the text as fast as possible into something like SOLR. So you can use Chemistry if you want a highly structured view on the data, or Manifold CF if you just want to hoover the whole lot up, put it in your Hadoop cluster and analyze it. So, we've got about 3 minutes left for questions. You're probably all stunned, but as I said, I will be putting these slides up online in about 5 minutes' time. Have a look through, try and see the ones that maybe interest you. Find me later on if you want, and I can try and tell you a little bit more about them and also point you at more information about them. I don't know a lot about many of these. It's trying to give you an overview, but hopefully it's piqued your interest, given you some things that you can go home, read about, learn about, and use to build your solution rather than reinventing the wheel with only those pesky 3 sides. So, any questions in 2 minutes, or do you just want to go and breathe and think? I'll take the stunned silence as a no. Come find me at 6 o'clock, bring me a beer, and I'll talk to you more. Thank you.